Hi everyone, so today in this video I'll be explaining a project where I have to create a cluster using Docker containers and Kubernetes. So first of all I have to create three nodes named as Edge, Fog and Cloud. So this is the main objective, and after creating the three nodes we have to follow such data constraints, like for talking about security sensitivity. So if it is a security sensitive task, so it should be run on only on edge nodes, and if it is a non-sensitive task, so it can execute on any of these. Same goes with the other constraint for data access frequency, like if the data if it is frequently being accessed, so the data is going to be stored on these nodes, and if it is less frequently accessed, so the data will be stored on cloud node. And we have to take care of this too, like we have to make the latency for edge node as 1 millisecond, and for fog 5, and for cloud 100 millisecond. So this is the basic system architecture, like where we have to create 15 edge nodes, basically like 15 containers for edge, 10 for fog and 1 for cloud, which will be going our to be a data center. And these are the constraints, like it has high latency, large storage and high computing power. And it like these nodes are going to be close to the user, and this will be far from the user. And then we have to create a task controller and scheduler, where the task controller, in this the fast API and delay logic is going to be implemented, and task scheduler will schedule the tasks with a delay of 5 millisecond, and the task created will be depend on on which node it is going to be executed. Then we can use these tools and technologies. For my project I have used Docker, Kubernetes and FastAPI, like we have created a microservice, and Python for a backend. Then this is basically the implementation steps. So starting with the step 1, like setting up the Kubernetes cluster, where we have to create these nodes, 26 nodes. So for this, these are the commands basically, where for creating 15 edge nodes we have to use this command. Basically I'll be running my PowerShell as administrator, and here I'll be first of all showing my process state. So as we can see, we are having total of 26 nodes till here, and each node is mapped to a specific port, starting from the edge 1 to 15. So these are mapped to the ports number from 8002 to 8015, and from 8101 to 8110 are mapped to fog nodes, and similarly for the cloud, this is the port number I have specified. So after this, if I just show you the next step. So for creating the 10 fog nodes, we have to take care of this command, where this basically just a second. So just like I was so for creating the 10 fog nodes we have to write this command, and for creating the cloud node we will be writing this command. So here basically minus d or hyphen d, it is basically like it will run the container in detached mode. And for like this hyphen hyphen name cloud, so this will basically name my container as cloud, and hyphen e like this node type equal to cloud, so it will be setting my environment for node type to cloud. And this 9001 colon 80, it basically maps my host port. This is my host port, so it basically maps this host port 9001 to my port number 80. So like we can fetch like the fast API app on my local host if I run on this port number. Then for running the task generator file, like if I show you the code, here we have controller and scheduler, this one, and here we have two codes for, and like basically in my controller the fast API task controller with is being implemented with my delay logic. And if I talk about scheduler, so this is going to, like this is basically a task generator script for the dynamic job description. And the failover logic is also being implemented in my this task generator file. So if I proceed further, then after checking my all process states, so let me just see my docker. So here as we can see all the nodes are in running state. Then if I just then I have to execute my task generator, yeah, this one. So then I have to execute this task generator file, which will basically start creating the task. If I show you, so like this, it is going to start my task like this. So after creating my task generator file, so this will start creating task one by one, like after with a delay of 5 seconds. So and in that you can see like the if the task type is sensitive and data frequency is high. So let me just check here, and if I just clarify once, so we can see if the data we were saying that if the task type is sensitive, so let's just match here. If the task is sensitive, this one, and data frequency is high, so it can either run on edge and fog. But in our case we have a constraint that if it is a security sensitive task, so it should be execute only on the edge node. So we can confirm like here this after we get the response that status is success and message is like that task executed on edge node. And like this random tasks are going to be generated for each, like after a delay of 5 seconds. Then after running this task generator file, we can just go to our local host, where this is the by default URL, and here we can see the node type is edge, and these basically like these number as you are seeing, these are nothing but the successful task that has been executed on this edge node. And same we have for fog node, and same we have for cloud node. So if I just reload this once, so you can see it is updating in real time, like the task is being created and being executed on which node, so by that it is being updated like if I just again update, so you can see the number of tasks which are is being successfully running on these nodes. So if I just reload this also, so you can see it has changed the values. And if I just again, so you can see this one, and same for the cloud nodes. So these are the successful tasks that has been executed on the cloud nodes. So if I just again reload, so you can see this many tasks have been generated. So if I just again reload, so you can see this one again is being mapped to cloud node. So coming back to our document, so these were the steps. Like first we have to set up the Kubernetes cluster. Like basically in this step we have to create these 26 nodes labeled as edge node, fog node and cloud node. So either we can do this using kubectl, but in my case I have implemented this using Docker. So after creating these 26 nodes, we have to deploy a fast API based task controller. Like basically we have to create a microservice which will like handle the executions, the task execution based on the constraints. And these constraints are nothing but these one. But these constraints we have to follow. Okay, then if I show you the code, so this is the my task generator file, where basically I have created a list of task type and frequency types. Like we, as in the document we have been mentioned, like we have to take sensitive or non-sensitive task, and frequency can be high or low. Then creating the nodes, like we have the edge node, and this is the port number I have mentioned, and I'm running this for 15 times, like from starting from my one number one. So like we have to create 15 edge nodes, so basically I'm running this loop 15 times. And same goes with the fog node, I have to run this 10 times because I have to create 10 fog nodes, and I'm running this as a single time because I have to create a one single cloud node as data center. Then I have a function generate task which will basically like randomly generating the task. If I show you here, like these number of tasks are being generated with a delay of 5 seconds, and these are just a random task. Like it can be like here we can see the task type is non-sensitive and data frequency is low, so it will be mapped to my cloud node. And these are, you know, like random tasks that are being generated with a like delay of 5 seconds. And if I just come back to my code, then I have to choose a node based on my task. And here I have used the if else condition. Like if the task type is sensitive, so it can either run on, so it has to run on edge node. And based on the data frequency, if it is high, so it should run on my fog node, else I have the remaining task have to be run on cloud node. So coming back to my talk, then after running the code for my FastAPI, then step 3 is to implement a task scheduling logic, where basically I have to implement a scheduler, like which will decide where the task should run. Like as I have said, we have to take care of these constraints. So similar that steps we have to follow in my step 3. Like this is my scheduler code. Yeah, this one, task generator. So then after this, yeah. So then step 4 is to deploy the task scheduler. like this I was saying, we have to deploy with a delay of 5 milliseconds, 5 seconds. Then step 5 is like where we have to basically monitor our logs, like how many nodes are being created or what are their status, their active state. And like, so like for this we have basically Prometheus and Grafana. Like basically Prometheus, like it collects the data. Like suppose as in this case we have three nodes, um, cloud, edge and fog. So suppose we have the number of task running for edge is say 9, and for fog is 2, and for cloud is 4. So it means like this number of successful task has been like, it basically means like this number of this successful task has been implemented on the respective nodes. And for my grafana, it is like basically for visualizing my data using my uh, grafana, sorry, Prometheus. And like it should be configured to pull the data from Prometheus, like where I'll be showing you just in a while. So this I am talking about. So here we can check for, if I so this graph has been, like if I just execute this once again. So this number of task, like we can see like this node type is fog, and we can see the status also. And for this we can see that the node type is edge and fog and cloud. Basically for my matrix, and if I just take the another one, so this will basically give the my all over overall latency. And similarly for Prometheus, sorry, for Grafana. So basically I have to first add a data source where I'll be searching okay, okay. Yeah, this. So basically I'll be searching my data source Prometheus here, and I have to configure this. So I'll be giving this name as a Prometheus, and this is the port number which I took from here, like as I have mentioned this in my code. And after taking this URL, I'll just scroll down and I'll just click on save and test. So here I'll see my live dashboard where I can select a metric for say H fog. Just check this one. So this is my three nodes, my edge node, fog and cloud node, and we can see this number of tasks has been successfully created on these nodes. So these extra is showing because in between I have restarted my these nodes, I'm saying. So I have restarted these nodes, then it is showing a breakdown here. Here I'm saying this one. So this was the overall project idea, like where we have to implement three nodes or containers with these security, like these constraints, and basically then visualize it. And first we have to monitor, like basically first collect the data for, we are like fetch the data in real time using my Prometheus, like which will collect the logs, which will be using for my monitoring purpose, and then visualize that in Grafana by configuring the Prometheus.